Hi there. I promised that I would post a video to help you prepare for the practical part of Midterm 1, and in particular stepping you through the answer key of assignment 6, which is important for you to pay particular attention to, mostly because it'll show you the level of detail that I expect to see on your write-up of the midterm, and I'll point out some things to be careful of when you're writing up your midterm. So you'll definitely want to pay close attention to the answer key for assignment 6, as I have said in class many times. Now, I am not in this video going to talk in detail about how to do an error analysis, because we've talked about that many times in class, and because the last 3 videos that I posted before this all are focusing on that. And so you should definitely be familiar with what's in those videos before you listen to this one. I won't repeat all that content now. Okay, if you look at the folder that comes with the answer key for assignment 6, the main file that you really want to pay attention to is the write-up of the solution. This is what's most directly like what you'll turn in for the midterm, although these supplementary files you'll turn in too, and definitely do turn in the files that the midterm requests, because they're all worth points. But the part that this video is really focusing on is how to do the write-up. But in the answer key, you'll see how I split up the sentences data set into a cross-validation set and a dev set. You'll also see, for the cross-validation set, the extracted baseline features and also the extracted final feature set after I go through the error analysis process. Okay, so let's look at the write-up of the assignment 6 answer key. In the beginning, I talk about how to divide the data set into a cross-validation set and a development set. And you can also see that in one of those videos about setting up for an error analysis that I just pointed to on the YouTube channel. Once you have done that, then what you're going to do is go to the Extract Features panel and load the cross-validation set. And you'll see that there are a lot of screenshots in this answer key, and I'll expect to see screenshots also in what you turn in for the practical part of midterm 1, so that I can verify your process. Because really what I'm going to grade you on is your process. I'm not going to grade you on how much improvement you get, or even if you get an improvement. It's even okay if your final feature space is worse than the initial one. I just want to see that you understand the process that you should be going through. So the first thing you're going to do is evaluate your baseline performance in a cross-validation, and I've given you explicit instructions on the settings that you should use for that. In particular, using support vector machines from liblinear, as you see, using a random cross-validation, and no feature selection. And so now you're going to run that experiment. Okay. And note what the baseline performance is, both in % correct and in terms of kappa. Now that you have that baseline result, that's what you're going to compare with when you have your final feature space. So the final evaluation you're going to do will be another cross-validation, but this time with a revised feature space. And then you're going to compare the performance across those 2 cross-validations. But the bulk of the time that you'll spend, both on assignment 6 and also on the midterm, will be actually doing an error analysis. Now, to set up for that error analysis, as we've always done, you have the cross-validation set loaded on the Extract Features panel, and now you're going to load the dev set as a supplied test set on build models. That way, when you're running your error analysis, you'll train on the whole cross-validation set and test on the dev set, so that when you do the error analysis, you're looking at instances on the dev set. You're not looking at instances in the cross-validation set. So the accuracy that you get when you do the experiment training on the cross-validation set and testing on the dev set should be somewhat similar, but it probably won't be identical to what you got in the cross-validation. Now you're going to go to the Explore Results panel, and that's where you're going to set up for an error analysis as usual. And once you have set it up, you should take a screenshot, again, so I can see that you're doing it properly. And in particular, it's going to be important to me to see which columns you have included, And to note that you have sorted properly on either the horizontal absolute difference or vertical absolute difference, depending upon whether you're doing a horizontal comparison or a vertical comparison. And you should pick out 2 problematic features by a horizontal comparison and 2 problematic features by a vertical comparison. You should tell me which features you picked and why you picked those as the ones that you thought were promising for doing your error analysis. Now, once you have picked those features, the next thing you're going to want to do is actually look at how those features play out in the instances within the cell where you're doing that error analysis. So now this is where you start to do the real troubleshooting. You've identified which features seem to be associated with errors, but you need to reason through why those features are confusing based on where they appear in examples. So what is it about those examples that the model is missing that leads to those features confusing the model? I want to see some hypotheses here. Then I'm going to ask you to think, what would be richer features you could add that would be less ambiguous and therefore less confusing than the problematic features you found? You should not try to fix the problem by removing those problematic features, because as part of the definition of a problematic feature, they have high weight. That means that the model is making good use of them. If you just remove them, then you just throw away the good performance that they're giving you. What you really want is to give the model more traction, the ability to distinguish between the places where it should trust those features and where it should look to other features to help with the classification. And that's why you want to add features and not remove them. Now, I want to see the reasoning for why you're adding the features that you are. How is it that your thinking about those features as promising is related to your understanding of what's confusing about the features in the current data set? That's what I want to see. And you'll see some examples of that kind of reasoning here in the answer key. And that's at the level of detail that I expect on the midterm. But note, in the past, I've seen some students actually copy text from the answer key into their midterm solution, even to the level of picking the same features as problematic. If you do that, you will get 0 points for your error analysis, so don't do that. I really want to see that you know how to do that. That's what the midterm is testing, and everyone should have had enough opportunity to practice before the midterm that that's a reasonable thing to test at this point. Okay, so you're going to talk about what was your idea. Okay. Oh, one other thing I should have mentioned is that when you're writing up your thinking about what's going wrong, I want to see real examples you took from the data. I see this feature showing up in the following contexts. So actually list examples that you saw when you used that bottom portion of the error analysis interface. So just as you'll see that I've listed in the answer key examples, concrete examples, you should list concrete examples and then talk about how you're going to fix those problems and why you think that they should fix them. Now, you can be wrong and you won't lose points for being wrong in your reasoning, but I want to see that you made an attempt, because over time, as you keep going through this process, you'll get better and better at it. And so I'm not worried if you're still working on your intuition now, but if you have the process down, then you'll know what you should keep practicing. And ultimately in your career, you're going to continue to develop these skills over time. This class just gives you the foundation for those skills. So you'll see in the answer key that I have proposed to add some regular expressions. And so you see that I'm adding those now on the extract features panel, and I took a screenshot of that to show that was being done. And now I can, I've extracted those features, and now I'm going to do my second evaluation. And this evaluation is going to be cross-validation using the new feature space. Now you might say, oh, isn't this the third evaluation? Well, I mean like an evaluation of where I'm at. So one of those experiments I ran was to set up for the error analysis, I'm not calling that an evaluation per se. The evaluations, which are measures of how good my setup for a model is, are all done in cross-validation over the cross-validation set. Now, if this was you working on your project over the semester, again, you're going to use your cross-validation set to run cross-validations throughout the semester. And those results on the cross-validation set are the ones that you're going to compare to see how you're progressing throughout the semester in terms of performance value. You won't think in terms of how is my performance on the dev set from round to round comparing. That's not going to be as informative as how well you're doing on your cross-validation set, because you haven't looked closely at your cross-validation set. You have looked closely at your dev set. So it's a better evaluation of the generality of your ideas and how well they really will do for you. And if you were going to use this model in practice, when you look at the performance value over your cross-validation set. So you'll see here, after I've extracted the new feature space, then I'm going to go to the Build Models panel, and you'll see that I've selected that new feature space. I've set up to do cross-validation instead of using a supplied test set, and then I click Train, and I am going to take a screenshot so that I can see that you have done that properly. And I report the results, and now I can compare on the Compare Models panel. I make sure that there's the first model that I built, not the first, well, okay. When I say the first model I built, remember that when you run an experiment, first it does a cross-validation, and it builds several models in the midst of that cross-validation, all of which it throws away. But then after that, it trains a model over the cross-validation set. And so you can think of it as a model. It would be the model that you would see if you went to the error analysis panel right after cross-validation. But of course, you're not going to do that because you're going to train on your cross-validation set and then apply it to your dev set. Okay, so that was just to explain to you so you aren't confused by how I'm referring to this. I guess you could say these tags in the pull-down menus are really referring to the experiments that you ran. So on the left-hand side, I'm going to use the pull-down menu to get the first experiment that I ran on my cross-validation set. And on the right-hand side, the second experiment I ran on my cross-validation set. And you can see here that the features that I added have improved the performance significantly, because if you look down at the bottom, you can see the significance test. And you're going to have to run significance tests also in the practical part of the midterm. And then you're going to need to be able to interpret what it shows. If you see red on one side, green on the other, it means that's a significant result. You can also read the text and it says significant. Sometimes it'll be marginal. Other times it'll just say non-significant. And you should know what that means. If you don't remember what that means, go back to chapter 5, and you're going to report then whether your improvements have shown a significant improvement. Now, note, and again, this comes back from the understanding you should have gotten from chapter 5. Statistically significant just means that we can verify that it's non-random. We know that because of the confidence interval that we compute. It doesn't mean that the difference is big. It just means that it's not random. Okay, and that's the whole process. On the practical part of the midterm, you're going to go through this process more than once, and there will be lots of things that you will explain and report along the way, and all of those will be worth points. There will also be an extra credit problem on that practical part of the midterm that will allow you to make up some of the points that you probably missed on the thought questions. So, and in the end, your midterm 1 score will be the average between the two parts. So indeed, that will compensate for some of what you probably missed. People generally do less well on the thought questions than they do on the practical part. So this hopefully should bring up your grade a bit. And remember that there's also another midterm at the end of the semester, and also other extra credit options, and then of course the final project, which is worth 50% of your grade. So don't get discouraged. You can do well. Hopefully you'll be very prepared for this practical part of the midterm. Okay. Hope you're having a great spring break.